Hi everybody. In this video, you will see how we can work on visualization of a data frame, part 2. In part 1, I imported a data frame, iris data set, and then here, and then I saw the first exercise, which was plotting general statistics of this iris data set. So here I'm gonna solve the second exercise, which is write a Python program to create a bar plot to get the frequency of the 3 species of the iris data. So the first thing to do is I'm gonna import seaborn as SNS. Then I can create a plot here, figure axis, PLT, subplots, 1x1 panel, and fixed size would be 15 by 15. Then I can create bar plot by using SNS dot count plot. So in count plot, I can indicate which column I'm interested. So I'm interested in the last column, which is species. And also I can specify the data frame, such as data is iris data. So let's double check the spelling. So this last column is with capital S. So here it's gonna be, then we can also add other things such as title. So the title could be bar plot, and then PLT. Let's run and see. There we go. So the title bar plot, and these are 3 species, Setosa, versicolor, and virginica, which each species has the same 50 values. So the frequency of each species is the same. So it was the solution of the second exercise, bar plot. I'm going to solve the third exercise, which is write a Python program to create a graph to find relationship between sepal length and sepal width. So what is sepal length? It was a data frame that in part 1 video I showed. Sepal length is this column, the first column, and sepal width is the second column. But this data frame includes sepal length and sepal width for 3 species, Setusa, virginica, and also versicolor. So if I want to show the relationship between these one, better to define new data frame. For example, I can define the Setosa, for example. This is Setosa. That's a new data frame. I would say this is iris data frame, but which column I wanted to get, I can say iris dot species equals Setosa. So by running this code, we can extract the Setosa data and then store that information inside a new data frame calling setosa. So there we go. This is good, but this one should be capital S. And this one should be double equal because this is conditional statement. So I can do the same for versicolor. So the conditional statement should be iris species equals versicolor, and the third data frame is virginica. Then after creating these three data frames, I can do plotting the relationship such as PLT figure. Then here I can say PLT plot setosa. So this could be the x-axis. The x-axis should be sepal length. Just to double check the spelling, sepal length should be extracted. I can say here that setosa sepal length as the x-axis and setosa sepal wide as a y-axis. And I can also specify the color such as orange could be appropriate. And also I can define the marker size, for example, with dot. Then I think it's good. We can go and plot the next data frame because it is almost similar. So I copy paste here, but change the name of data frame. And also let's show it by another color, blue. And we can do the same for virginica data frame. And with green color. So let's run and see. Okay, there we go. So you see that the x-axis can also specify the x label and y label. But here I'm going to briefly explain the orange dot colors are setosa species, and it shows sepal length in x-axis and sepal wide as a y-axis. The same blue dots and green dots, the blue dots are for the versicolor and green dots are for the virginica data frame. You see there is a different category. I mean, the orange dots are completely different, which could be interesting in classification problem, and we will talk about that in the future videos. Thanks for watching this video. I hope you enjoyed. Please subscribe and like this video.